Hi, this is Mrs. Kidman, and in this video, we're going to be going over how we write equations or quadratic equations when we're given either the x-intercepts, the y-intercept, or the axis of symmetry, given some of those things. So as a quick review here, when we're talking about our intercepts, we have two different kinds. We have our x-intercepts, and that is where they cross the x-axis here. And then we have our y-intercepts, and those y-intercepts are where they cross our y-axis. So let's take a look at these two functions and identify them. So here's our x-intercept. It crosses right here. It's going to be between 3 and 4. It looks like it could be about 3.5, 3 3/4. Our y-intercept here is going to be at y equals 3, or usually we label this as the point 0, 3, and this one will be the point 3.750, right? We can kind of figure out exactly what that is. Now let's take a look over here at our other one. So our x-intercept here where it crosses our x-axis. So in this case, we actually have 3 x-intercepts with this function. And those intercepts are going to be at -4, 0, -1, 0, and 2, 0. So those are those 3 places. And then we have one y-intercept here, and it's going to be right here. Note, we will always have only one y-intercept if what we're graphing is a function. And in this case, our y-intercept is 0, -2. So using this idea of intercepts, we are going to base our quadratics on those intercepts. So let's take a look here at this first one. We want to sketch a graph that has the following intercepts. It goes through -2 on our x-axis and 5 on our x-axis. And then our y-intercept is here at 4. Now, interesting thing about this is our vertex is always going to be exactly in the middle between those 2 points. So if we go over 2 here, over 2 here, we still have 3 left, so we want to go over like 3/4 of 1, and our vertex is going to be somewhere right here, right between the 2, right? And then it's actually going to be symmetric about that x value between those vertex, because that's what our axis of symmetry is. So our axis of symmetry is going to be the difference between our x-axis, our x-intercepts, divided by 2. Okay, and so we want to figure out how far apart those are, or the sum of them, I guess, is how we figured out. Remember that axis of symmetry, we add them up. And it's also going to be symmetric there, so that means we also have this point here. So I know that my graph's going to be something like this. I can't tell you exactly what it's going to look like, but something like that. Now, what we want to do is write those equations. So when we're writing our equation, we have these points here that are important to us. This is kind of like giving us our x-intercept and our point. Now, this is super important because we are actually going to use the factored form for this. Remember, factored form looks like this. It's y equals a times x minus p times x minus q. And the key thing here of why we want to use factored form is that p and q, those are actually our x-intercepts on our quadratic. So using those x-intercepts, we can solve for a, and we can use that other point, just like we did in the previous lesson where we were given the vertex. When we were given the vertex, we used vertex form. When we're given the x-intercepts, factored form is based on those x-intercepts. So we can use them to write this quadratic. So let's take a look back at this first one here. So I want to write this in factored form. So if I'm writing it in factored form, that means that I'm going to write it in y equals a times x minus p times x minus q. Now the key thing is here, remember p and q are the 2 x-intercepts. So this one's p, this one's q. So I'm going to fill it out just like I did with that vertex form. Y equals a, I don't know what that is yet, x minus -5. And when we have a minus and -5, we usually write it as a +5 times x minus 1. Okay, great. So now we have this. And then our y-intercept here is kind of like a point that we can substitute in. Remember, that y-intercept is going to be the point 0, comma, whatever it is. So this y-intercept is actually the point 0, -2. So I want to plug that right in here, and I can use that to solve for a. So let's plug it in. We've got y equals -2, and then I don't know what a is, but x is going to be 0. And then 0 minus 1. So we've got -2 equals a times 5 times a -1. And so that means negative 2 equals a times negative 5. Let's divide by negative 5 on both sides. And a equals 2/5. So that means when I'm writing this equation out here, what I actually have is y equals 2/5 x plus 5, x minus 1. And that is how, when we're given the x-intercepts and another point, any point, whether it's our y-intercept, things like that, how we can write our equation there. So let's take a look at this next one all together. We're going to do the exact same thing. So remember, we want to be in factored form. So y equals a times x minus p times x minus q. And remember, this is p and this is q. So let's substitute it in here. Y equals, I don't know what my a is yet, but x minus 2 times x minus 7. And I'm going to use this point where the y-intercept is 5. So what that means is I have this point at 0, 5, and I want to figure out what a is using that point. So let's do it. Y equals 5. I don't know what a is, but x, we're going to use a 0. And let's simplify it. 5 equals a times negative 2 times negative 7. Well, negative 2 times negative 7 is positive 14. So 5 equals 14 times a divided by 14 on both sides. And a equals 5/14. So what that means is when we write this out, I've got y equals, instead of a, I'm going to write that 5/14 times x minus 2, x minus 7. And boom, we've got that equation written. So this works when we have those x-intercepts and our y-intercept every time. Now, the other one that I want to look at is, instead of giving us the y-intercept, now I want to look at an example where they have it run through a point. So we're going to do the exact same thing we did here, except for instead of substituting in our y-intercept, we're going to use this point. So again, we're still going to be in that factored form. Anytime they give us the x-intercepts, we want to use this factored form here. So let's take a look at it. I've got y equals, this is p, this is q, and a, I don't know what it is, x minus negative 3 is the same as plus 3. X minus 4, and then I want to use this point to solve for a. So I'm going to substitute my y value in, equals some number a times 1 plus 3 times 1 minus 4. So let's simplify this. 12 equals a times 4 times negative 3. 12 equals a times negative 12. Let's divide by negative 12 on both sides, and a equals a negative 1. So then when we're writing this in that equation, what we want to do is take our negative 1 times x plus 3 and x minus 4. And that is how we're going to get that. So again, we're going to take our x-intercepts, put them in our factored form, and then use whatever point they've given us, whether it's our y-intercept or just another point, and use that to solve for a. And then we'll have that equation in factored form. So I want you to try one example on your own before I let you go. I want you to go over this problem, pause the video, write it down on a piece of paper, work it out, your full solution. When you finish, unpause the video, and we will go over it all together. So take a second and do it on your own. Okay, hopefully you've had a chance to go over this one on your own. So we start by taking our x-intercepts, and we want to plug them right into our formula here. So I plugged them in and I got y equals a times x plus 1, because remember our equation has a minus here. So we want to switch the sign, plus 1 and x minus 6. And then I took my point and I substituted in the x and y values so that I can solve for a. Now I substituted them in and I simplified it, and I ended up getting a equals negative 7/12. Now, one of the biggest reasons why we want to be able to solve for a here is because you and I, just looking at a graph, would have probably never guessed that that a value was negative 7/12. But using this process of solving for a, we're able to figure that out. So then ultimately, we ended up with an equation of y equals negative 7/12 times x plus 1 times x minus 6. And that is how we can write a quadratic equation when we're given the x-intercepts as well as a point. Now this only works with quadratic equations. When we start having equations that are cubic or quadratic or something like that, we do need to make sure that we're using those equations. But because we're dealing with quadratics, we can use this factored form, and it's going to turn out beautifully. If you have any questions, feel free to reach out. Otherwise, good luck with your assignment.